How's everyone?
Good.
Good.
It's Friday of a very long week.
Oh, okay. How's everything in Splunk? The tough
fine.
week? That's fine.
Yeah, it's a long.
Okay. I think we can get started soon. And let me just double check. Everything is up running.
Okay, what was the format again?
So I think the format is basically, so I think it's a carry on from the webinar. And
Okay.
I think in the probably next couple of weeks, I would like to probably doing a similar format, try to like invite some of the people joining the kind of a weekly episode on talking about specific questions. So it's an interactive kind of video. Like it's more about like sharing experience and also some of the understanding about some of the features that that what are the best practice, and it's a kind of open dialogue, then like sharing about any like thoughts or any like backstory of those features. And I think and before that, I think as we had a discussion with Edison is on how to use kind of best use this format to discuss some of the popular questions that we can kind of help people really understand some of the like features of Pulsar. And Edison, you want to add something? There?
I was just going to say, we actually are live right now, by the way.
Oh, okay. Oh, you. I think
I was just
that is
checking on
fine.
YouTube.
Yeah. Okay. So I think okay, it's already live. I think that's fine. So basically, welcome like everyone to join today's TGI Pulsar episode. And I think starting from this week, we're kind of changing a bit format. It's a carry on from like our previous like webinar talking about how some kind of best practice on operating Pulsar in production. It was just like 1 hour discussion, but Pulsar has a lot of information. So we would like to use the next couple of weeks on discussing some of the topics that related to Pulsar. And I think we'll probably get started with some of the highlights of Pulsar that is kind of the most featured differentiator of Pulsar, and those are kind of the features that a lot of people would choose Pulsar. And for today, I think we'll get started from multi-tenancy. And before the show, I think maybe Matteo, Edison, you want to kind of introduce yourself, and then we can get that started.
Sure. I'm Addison Hyam. I work also at StreamNative. Previously have deployed and used Pulsar, are familiar with kind of how to use its multi-tenancy features, and interested in talking about it today.
Hi, I'm Matteo. I was at Splunk, and I'm one of the co-creators of Pulsar when I was back at Yahoo. And yes, I've presented myself many times now, so that's okay.
Okay. So people who is watching the YouTube now, feel free to kind of drop any questions. And otherwise, I think we will probably just like go deep, kind of talking about the questions or like the stories around multi-tenancy. So since I think one of the highlight features of Pulsar is multi-tenancy, and since I know like when Yahoo started a project, the idea of Pulsar is kind of creating a cloud messaging infrastructure. And Matthieu, do you want to talk a bit about like the kind of a story of multi-tenancy, and was it kind of the top requirement of cloud messaging, and how you kind of organize the design, and we can get the conversation get started. Yeah.
Sure. Yes, it was probably the first requirement, right? And that was based on the realization that I talked about briefly in the other webinar that was last week. But the main thing was that you have many product teams, product engineering teams that are basically forced to deploy their own infrastructure. All right, it could be like ActiveMQ, it could be Kafka, it could be RabbitMQ, like any. I mean, and that along all the services, right? And so the product team basically their mission is to build products, user products, user features. If you're talking about Yahoo, then it's Yahoo Mail, Yahoo Finance, and like all these or Flickr, like all the things. So they have their own goals, and that does not include necessarily to run infra software. So, but that's something that they were used to, they were forced to do because there was no alternative, right? But that was not working well, and it was not working well because, like if you do these silos, like in which each team has to do the entire stack, they cannot know like how to operate these systems. They don't know how to scale them. They don't know how to debug them, and they don't know exactly like what's the best deployment and so on, right? So like there's a lot of difficulties there, and that's very draining on these engineering teams. Therefore, like it is more efficient to have one team that is focused on just that platform, and that it can basically develop, scale, deploy, and maintain this platform, and just abstract all the complexities of running that through an API to these other teams. That is the main realization. So that we just need like a team of person that understand that piece of technology, and that can run it and fix it and improve it and so on. So that was the main motivators there.
Thank you, Matthieu. Since I think many companies are looking into Pulsar, what would be the kind of the first impression about like multi-tenancy? Since Instructure has adopted Pulsar for for more than 1.5 years, and do you have any like ideas or thoughts you want to share, like when you're looking into Pulsar regarding multi-tenancy?
Well, I think it's interesting, kind of getting a little bit back to what Matthieu was talking about, right? Like having teams that need to manage these services doesn't work well. So we knew already that we were going to try and platformatize messaging, and looking around at kind of the options there. It's pretty clear that a lot of companies do, use other systems for messaging, platform centralized teams. But it also became pretty clear that there's a lot of work and effort that goes into building up all of the tooling to make that happen, right? Like using Kafka's example, tooling for automating the deployment of Kafka clusters, including all the management aspects, including UIs and for to help visualize, as well as for doing access control, all these different concerns that you kind of have to take on. And as we looked at Pulsar and saw sort of that it sought to bring that all kind of under one roof, so to say. And even more interestingly, I think often we look at Pulsar, if you might be familiar with the tenants and being able to say, okay, well, I can create tenants on a cluster. But Pulsar also gives you the ability to take multiple clusters and still view all those with the same tooling, using the same metadata service. And so that further was kind of like, okay, we can also use this. If we do have some applications that really should be on their own cluster for various reasons, maybe they have different SLAs, maybe they have different vastly different usage profiles, we still can have a management layer that can do all that. So that was really attractive in being able to have all those things be sort of out of the box and be able to focus instead on the kind of the domain of our business and really the value that we get through messaging, as opposed to having to spend months to build out all of the tooling to really make a platform team. And that allowed us to really quickly start getting Pulsar deployed and then immediately start giving access to teams and to start playing with it and getting comfortable with it, and then really with a lot of confidence in that we could still manage it from a security perspective to then move into a more production-like environment. So I could talk more about, I think there's a lot of features, and maybe it's worth kind of digging into those features, but that were really useful to us. But
yeah, I think since you kind of mentioned about there's a lot of features around like multi-tenancy, and also I think multi-tenancy is also in different system, it might mean different things. And maybe like any of you want to get started to give kind of brief introduction of what does like multi-tenancy mean, like of how like Pulsar provide these multi-tenancy features to the customers, just like for people who is new to Pulsar, just get started exploring Pulsar and comparing Pulsar with different messaging system. If we can get kind of a simple introduction in terms of like what exactly Pulsar offer in multi-tenancy, that will probably a great introduction.
Okay, I can start with a brief intro. So the main idea of multi-tenancy is that yes, you have multiple teams, multiple users on your single cluster, right? So yes, you have one cluster and you can share it across multiple users and multiple workloads. That's what's important, right? So there are two main aspects of it in my view, and so one is the access control part, right? So you want to have basically these isolation in terms of which topics I can use, and how can I get the stats from my topics? How can I do operations on my topics? How can I configure different options on my namespaces and my topics and so on, right? And I get back on the namespace and tenant concept, but the second aspect is more as a system design, and this is like, sure, you can have this access control, but if user A is doing something and that takes down the cluster or impacts the performance on the entire cluster, then how is that good for, right? So sure, you have all these permissions and stuff, but if you don't have these isolation from I mean, not just bad behavior, but also like in terms of like, you need to have each user should have a set of guaranteed behavior, right? In terms of latency and throughput and the storage as well, right? And so that is the second aspect. And if you consider then from a user perspective, from a system perspective, the benefits of multi-tenancy then is also that you can have better hardware utilization, right? The more users you have, more tenants you have in your cluster, the more you can basically over subscribe your cluster, both in terms of throughput, right? Because like the traffic patterns for each tenant is not uniform, like that typical like if you're at Yahoo and you have multiple products, they will have the different traffic patterns, right? So and typically, like if you need disk storage to handle large backlogs, and typically, like, not every tenant will have an outage on the same day. So sure, it can happen, but you typically want to basically like oversubscribe that portion so that you can you don't have, like, if you have 10 tenants and each can use say up to 10 terabytes each or of data, you don't want to have like 100 terabytes. You just need to maybe have 20, right? And then you have basically everyone has one, and then one tenant might have 15 terabytes of backlog, right? So and tomorrow is a different tenant. So that's kind of the saving. Kind of like digress a bit, but so we talk about there are ACOs, and there is these more guarantees of the multi-tenants, right? So if you look at about the ACOs, is like the first thing that I think that we are doing different from other systems is that we have these 3 layers of like this hierarchical model of tenants, namespaces, and topics, right? So, and the reason that we chose that to begin with was is that you want to have like in a self-managed service, you want to give a tenant the permission to administrate everything under its domain, right? So, and each tenant might have multiple namespaces because there, and you can map it as you want, but you could see one namespace has I don't know, like one use case. So you have like tenant X. Tenant X has application A, application B, application C, or like different microservices, and each of them has its own set of topics. So you want to group these topics each on its own namespace, but at the same time you also want to basically group all these namespaces on this tenant. That's why we have these 3 layers. So with these 3 layers, like then basically you can allow that tenant X to create namespaces under its own domain without any intervention from the system administrator, right? And that like you are completely free to administer within the constraint. So that is the first thing on the and then on how the system is providing like a more like a rigorous isolation across different tenants, then it's a longer discussion. So I think we can also break that down into smaller pieces.
Okay. Absolutely. Thank you for like kind of a brief high level introduction in terms of like the what the original Yahoo team has been thinking about how to organize this topic in a hierarchy, in a topic hierarchy, and introducing tenants, namespace, and topics into kind of 3 layers. And it's not just about the access control, but also kind of balance of providing a way for managing the control the resource allocation and also isolation. And I just wondering what Edison like when you adopt Pulsar in structure, when you first time like view this hierarchy, like what is your impression, or like how you are planning to use this kind of hierarchy? Because I think that is a very common question that will coming up in the community again and again. What is the best practice to use this 3-layer hierarchy? I just want to hear about your opinion.
Well, and I mean the kind of the answer that nobody really wants in some ways is like, it depends, right? Like there's a lot of different ways to look at, I think, what Pulsar offers, and in terms of organizational primitives, and to kind of, you know, there's no cut and dry, you know, way I think that is a one size fits all for everybody. What we found that was useful was to first kind of condense that down into a few different patterns, right? As like, hey, are you going to have, you know, we're as the team that is owning Pulsar, we're going to take care of all the operational aspects, but how much do you, as a little bit of background coming from the company, there was a few different, larger engineering groups that were working on not just, one service, but multiple services. So they might have underneath them, 20 or 30 different services. And so it's sort of a question of, well, how do you want to manage that? Would you like to manage that such that you can, each one of these individual services can have a tenant, which has some of its own benefits, right? Like you're giving a lot more autonomy to teams. They can organize kind of how they see fit, but that maybe comes at some cost of sort of, some visibility, or somebody who's maybe the kind of the domain expert on Pulsar being able to help and assist teams in a really, be kind of the tenant admin and really help to kind of have some more control over that. And honestly, we actually did both. We had some teams that went one way and some that went another. And what we sort of found is that in the longer term, a lot of that more tenants, there wasn't too much of a cost of more tenants. We could still kind of manage that, and using sort of the ACL policies, we could let some principal, some user, manage multiple of those tenants, and it wasn't too high of a cost. And so I think, that's maybe one of the things that at least we discovered was that, wasn't hundreds of tenants, but, as opposed to like sort of one tenant for an entire product, we might break that tenant into 4 or 5 different parts, maybe belonging more aligned to the teams of what they were working on, or, some domain of the product. And then kind of to Mateo's point of namespaces is what they offer is not just a grouping of topics, but also a common set of settings that kind of define some characteristics of how those topics tend to work, right? Like if you're going to set up a backlog quota for a namespace, that those policies are set on the namespace. Similarly with things like offloading and retention policies, right? And so what we, once to Mateo's point, sort of found that it often made sense to kind of have a namespace for an application, but an application may have multiple namespaces depending upon its use case. It had a use case, 2 different aspects of a application or a service might have 2 very different use cases. They would, want to have 2 different namespaces to sort of be able to put those messages in sort of the configuration, the configured namespace that best matched sort of its use case. But at the same time, there's oftentimes for some of those topics, we would find it wasn't worth that. And it might mean that this topic didn't need to have as much retention as bare minimum, but with things like tiered storage, it made the cost of that, or, the cost wasn't so high that we would just say, okay, that's fine. So I think for us, a lot of it was, to kind of summarize, was more aligned around tenants that are probably closer towards a team, and then namespaces that were more aligned around, individual services or applications, and then using more namespaces as needed to really kind of match for the use case. And then as much as possible, trying to kind of give teams, using the pools that Pulsar provides to let teams self-manage that as much as possible, and us just to kind of provide some guidelines of like how to set things up, and then, let teams, we found that would really worked well. Teams were able to kind of understand and start setting policies that they needed pretty easily. So.
Yeah, thank you, Edison. I just like curious. I think a lot of people, use a very similar pattern as what maybe Edison described, and I was just wondering from a creator perspective, Mateo, are you kind of seeing this is the common pattern on how people using multi-tenancy in a way you design that to be used, or you are actually seeing like people are using multi-tenancy or kind of architect the tenant namespace topic in a way that you didn't really expect people to use?
I think that, yeah, there's been a mix and match. in some cases, yeah, I mean, people say, okay, I like if, especially like if people are like running Pulsar in multi-tenant model, they will tend to use the tenant and namespace as we were like thinking at the beginning, right? Because they have tenants and they're like their own teams. Like when people like are deploying Pulsar more like in a not as a like a internal company service, but more like, okay, I need this piece of infrastructure, I will run it, and I mean, not truly like multi-tenancy in a way, like in concept, right? Then they might a bit diverge more in that approach. But it's fine. I mean, this is just like this is just like meant to be kind of like a flexible hierarchy or of permissions, right? So in this case, like people might say, okay, I don't need tenants because I don't need that concept. So I just use one tenant and just use namespaces on it. Or I can say I can use tenants, but I don't use namespaces. I have like a default namespace and I just use that, and that's about it, right? So either that or like a different association of what a namespace is. For example, like in some cases, like one of the things that we also saw is that you might have applications in which that they're using one topic per each tenants, but that's their own tenant, right? Let's call it a customer, right? So they have customers, and therefore, like for these applications, the Pulsar tenants is the application name, right? So you have application X that is doing something, and this application X needs, for example, like a few topics per each of their customers. So in this case, the namespace becomes the customer name, and within that namespace, then you have say 3 or 4 topics. So in this way, you can administer like each customer on its own. So yeah, it's kind of different, but it depends on needs as well, right? And to conclude, yes. So what Adson was saying was he was mentioning that yes, it is also a way to. It's kind of like the administrative unit that we were talking since the beginning. So namespace is the unit of administration, and that is in one sense it is good. In one of the senses it's also limiting. I think that one thing that we are missing is that some of the policies are not configurable per topic, which is I mean, could be improved. Let's put it that way. And that stems from the fact that our principal concern was how can we efficiently administer many topics at once, right? That was our main problem. More than how to have more granular access to configuration. So that's why we have these, that you have a namespace and you are able to set the policies, do one call, and everything is set for thousands and thousands of topics, right? So, which if you have to do it that one by one, that would be impractical. Also, like to audit, okay, what is the configuration here, and how can you be sure that all the topics have the right configuration. So that's where it came from. But I think that we should improve. I think in some cases it has been improved, but we need to make sure that it is we can configure every single policy on the topic itself.
I see. So since I think both Matteo and Edison touch kind of one point is the multi-tenancy or the topic hierarchy is not just about the access control, but it's also has some indications. Like for example, Pulsar has this concept called namespace policy, and use the namespace policy to manage the same setup, the topic that have same settings, but I think there's also because it's a very useful mechanism that people can kind of configure different settings for different namespace. But it also lacks some of the functionality as what Matteo just mentioned it, because we don't have a topic level policy, and we don't have a kind of tenant level policy. So this kind of mechanism might mislead like people on how they want to map their topics into the topic hierarchy. And what's your thought about that? Is any recommendation on that?
Yeah, I mean, I think there definitely are a few, just to kind of, there's certain settings that currently kind of exist at the namespace level, but are more intended to be managed by sort of, the cluster administrator. Certain permissions that may have an impact on the cluster, and so that's sort of another aspect to that, right? Is how do you best make more of maybe a customization to those namespaces, but that's not now some policy that can't be set directly by like a tenant admin, and so that is kind of another wrinkle in sort of a bit of the complications that I think of that to use multi-tenancy. And what we sort of found was that in most cases we could come up with most of those policies that may only be set by the kind of propagate down to the namespace, but can only be set by a super user in the cluster. Most of them we found that we could find really reasonable defaults for most of the use cases, and set those as cluster-wide defaults. And then in those few cases where we did need to change something specific to a namespace, that we could write some really kind of lightweight automation to help customize those few things. And then that sort of aligns with some of the things you're talking about around like, tenant level policies versus, topic level policies. Is I think a lot of these things right now, that some kind of low level or high level automation to just help tweak a few settings here and there is a pretty good way to kind of help alleviate some of those pains. And so that's that from a getting into the weeds, that's what we found and seemed to work with that. I think I'm talking with other people in the Pulsar community, similar things have been done. But kind of getting back to your original question there, that is mostly what our team. One of the things that we were really looking into to also figure out what more improvements could happen is how to make some of those either to allow a more granular permission system or to make it a little bit more flexible to kind of really give people full management, to safely give out the management of things that we wanted people to be able to manage.
Matteo, do you have anything to kind of add on to what Edson just shared, like his thought on like the this namespace policy topic?
Yeah, so it can be confusing. I agree, and I mean the main reason for that is it kind of like grew organically, right? So initially, like it might have made sense, like have these namespace policies, and then like people have been started like adding more and more features there, right? And making those features configurable at the namespace and so on, right? So I think that's why it ended up in this in the current state, which you have these some features that are like system related, some features that are like some like a very user-facing features related that can be enabled. I think we could do a better job there to basically to have like a consistent model on everything, and also like a consistent like override model, right? So like for having like from system defaults to tenant defaults to namespace defaults to topic override, right? So as the same like as we have like in these ACL hierarchy, we should have also like these hierarchy of policies that can be attached, right? And I think that requires some refactoring in that, but it shouldn't be too hard. I think the main thing would be to just really do an overall of what policies are, who can set what, and have these implementation that can allow for overrides at every layer in that hierarchy. I think that will make it more easy to reason about, I believe, so that you don't have to model your structure based on which settings do you want to apply. That is something that is, it shouldn't matter, right?
Yeah, I think that is, so basically, I think, Matteo, you touch a one major point in the multi-tenancy is, in the multi-tenant system, there are actually two type of users. Like one is the system operators, and the other one is the end user, like who is using this platform. And I think there are a couple overlaps that in between the tenant, and also there's some in the namespace policy, there are different type of operations, and some operation might be only allowed for like tenant admin. Some operations are only allowed by super user, and some operations are allowed by the end users. So when you originally designed these system, like what is the thought behind of designing this, I would say, the authorization system in permission control on isolate the system operation from end user operations. And the reason I bring this up is I would like to use this chance to help people understand like the relationship on different roles, and when people looking into the permission access control within Pulsar, they would have a better idea how the system was designed and how to leverage those functionality in the best way.
Sure. Again, so some of the things are, I say, they grew organically, right? So like if you were to start right now, like having all the features that we have right now, and say start from scratch, that all these authorization model, probably it would look different, right? But then that is like with the like having like hindsight of the future, right? When you start with the solving one problem, you typically think that problem maybe the next one, maybe the two next ones, but you don't think about like 10 features ahead, right? So the main reason that you have these some settings that are only allow for a super user, even at the namespace level, is that these are typically settings that impact the stability of the system itself, right? So if you have tenants, so a tenant should be able to, I don't know, enable features like, I don't know, applying TTL, for example, or setting retention. These are all things that depends on a use case by use case, right? So if your use case needs TTL, sure, you should be allowed, you as a tenant, to set your own TTL without asking the system administrator to change it for you, right? That's the main concern. And that really depends on your application. On like for TTL in particular, is that okay? How much time are you willing to wait for the data, and then if you're not able to consume it, throw it away, right? That's really like, as a system administrator, I cannot know like what is your time, right? Or if any, like if you even want a TTL, or you want to just keep it forever. Versus that there are like other changes that are more like reserved to the administrator. Like for example, like throttling is one, for example, right? So if a system administrator sets throttling to say to 100 megabytes per second, a tenant shouldn't be allowed to say, "Oh, I want 200." You shouldn't be allowed to do that, right? Or there are also like some things that are like features that can be can, especially like for new experimental features, we would typically want to have a flag and opportunity for the administrator to turn it off, right? Both at system-wide or even like a namespace-wide. So you want to basically, I don't know, selectively allow. So we, I don't know, added a new feature. One example, I don't know, like just making it up, but delayed delivery, right? When we first introduced it, sure, the feature seems to work. We don't know for sure like what would be the impact at scale of this, right? If people start using that like crazy, and what would be the impact? So when we started, we said, okay, we can just selectively enable that on namespace. It's a way like to reduce the risk, right? And a way to turn it off if it's not working or things like that. So it's more like have the system administrator, the super user, to have the freedom to always intervene and make sure that the system is stable.
I see. So in other way to kind of interpret that is in the namespace policy, there would be kind of the namespace policy is probably serving in a way is on like a control feature flags that turn on some of the tuning in some of the features. And also there's some policy related to, I would say, system resources, resource quota. And so for this kind of, for feature oriented, might be able to kind of offload some of these feature flags to be shared between like administrator and the users. But from resource perspective, you want the system administrator or the cluster administrator to be able to control like how to allocate those resources. That is probably a very high level kind of separation on those kind of the settings in the namespace policy. Is that a kind of accurate claim in a way?
Yeah, okay. That's correct. Yeah, so the policy that I say is it is stored in the same place in metadata on the namespace policies, but yeah, it is really two sets of different settings, really.
Cool. Since we touch a bit about a resource, kind of for the multi-tenancy, one side is about the access control or organizing the topics in the topic hierarchy and provide access control. On the other side is multi-tenancy is also about resource control. That is, you want to make sure from cluster administrator perspective, I'm able to allocate given resources to a certain tenant. And I would like to see if anyone want to kind of give the audience a high level introduction about what type of resource control and what kind of granularity that Pulsar is able to provide in the resource control side.
I can do that. I won't make Matteo talk the whole time.
Yes, go ahead.
And you know, speaking as somebody who wasn't an original developer Pulsar, but kind of came to the community, attracted by its features. That's also one of the things that really is a pretty nice feature set to have. And as I kind of mentioned this, Pulsar really gives you not just control of an individual cluster, right? So say I have my one main cluster, but also has some features around being able to take a given tenant and say, actually, I want this tenant to be on a different cluster, to be isolated from a different set of resources, which is related to sort of the quotas and whatnot, but also another really great feature is that ability to do tenant isolation and kind of use the same management API. And I think it's actually something that's not used super often either, but when for those use cases where that's actually now I'm questioning myself. Is it a tenant or is it the namespace?
Namespace.
It's at the namespace level, yeah. But yeah, the point still stands of being able to take some workload and push that off onto another cluster is a really nifty feature, particularly as you're kind of growing an organization and want to make sure that you can meet certain SLAs without any issues for maybe some of your most critical applications. But beyond that, speaking of the individual cluster level, Pulsar has controls pretty much at all levels. So there's the ability to publish, to throttle publishes to certain amounts of data. Also the ability to throttle how much reads can happen. And those settings are really useful for not stressing your network, right? A Pulsar cluster oftentimes can be network bound, IO bound on the network. And those settings can be really useful to make sure that you're not on an individual topic, you're not going to let that go too crazy and consume an undue portion of the network bandwidth. Similarly, storage size is also something that when you're running a Pulsar cluster, we want to be really aware of, and that can be done in multiple ways. And I think this is one of those things that there's often a lot of questions about, and maybe I don't know how deep we want to get into it right now, but the distinction between a retention policy and a backlog quota. A retention policy applies to messages that are outside of a subscription, whereas a backlog quota is a useful thing for controlling messages that are controlling messages that are still visible within a subscription. And those two things aren't additive, right? Like it's not just messages that are fall outside of a subscription. A backlog quota has to be bound if you've set a retention policy. If you're using retention policies, that a backlog quota has to be bound by what your retention policy allows. And so what that allows you to do is to make sure and say, I can set a smaller backlog quota and make sure that my subscriptions are never going to get way far behind to where they're just not realistically going to catch up, but I can still retain more messages. Or I can make sure the only thing maybe if you're not worried about retention after messages have been consumed, you may only have a backlog quota to make sure that that's the thing you care about most, is just making sure that the message gets consumed out of a subscription. And then there's also a lot of other limits that these ones are a little more esoteric, but not let somebody create thousands of subscriptions thousands of consumers to a single subscription. Those sorts of things can have could be indicative of maybe an application issue, or also just a design a problem where if somebody's trying to consume a single shared subscription with 10,000 consumers, maybe that might be outside of the realm of reason and put some undue stress on the cluster. I'm sure I'm missing some other ones, but kind of get some sense of all the different controls that are in place, and to really make sure that you can operate a cluster and put some guardrails based upon your hardware needs to lessen the likelihood of somebody doing some activity against the cluster that causes an impact on others.
Yeah, I think thanks, Edison. I think you give a very kind of great an overview in terms of like what type of the resource control that in place. But based on kind of try to summarize this is there's one set of the policies really focus on resource quota, like in terms of like how many tenants, how many producers, and how many consumers, like the storage size. And the other set of mechanism is more about the resource isolation in terms of like the namespace isolation policy. And I think the placement BookKeeper placement policy is also one set of the I think what it was called failure domain. So those kind of setting is more related to kind of resource isolation. And I just want to get some opinion from Matteo Is that a kind of accurate claim? And do you see there's any missing piece that related to the resource control?
Yeah, so it is accurate. There is a bit more to cover here as well, right? So the quotas are one part, right? Both quotas in terms of storage and quotas in terms of like throughput and so on, right? The other part is like how we use the disk, right? The access to the disk, and make sure that if the write throughput is not impacted when there is read activity, and this is basically mostly solved by BookKeeper, right? So that's not something that we do activity on the broker side. Is how BookKeeper handles that, and the important part on the storage is that let's say you have write activity. Typically, like the consumers are being dispatched directly from the brokers. The brokers are not reading. If the consumers are caught up with the producers, the broker will just dispatch from memory. So in a normal condition, the bookies will just see write activity, like 100% write activity. It's fine. So they're just there in case something happens, and that something happens could be that consumers are down. Consumers may be down for 1 hour, and therefore you can accumulate a huge amount of backlog in your subscription, or if you don't have subscription anyway, you can do like replay a whole bunch of data, and that data will not be in cache anymore, right? So if it's not in cache, then brokers will have to read from the bookies. The bookie themselves has some cache data structure there, but eventually they will have to touch the disk, and this is like one of the most critical parts, right? Because the moment you touch the disk, like if you're doing that in the wrong way, that can impact the performance, not like 30%. It can be like 5x or like 10x, like the amount of impact you can have on your throughput, right? Or on the write. So the way BookKeeper is doing that is like it's a very sophisticated storage internally, right? And we don't just rely on page cache, for example, like to do that. To solve it, because page cache is unpredictable, and it works well only if your dataset size is within your RAM size. So, but if your memory is, if your dataset is 20 terabytes, there's no way that you can fit everything in RAM, or even if it's like 200 gigabytes, it's difficult, right? So the moment you have a dataset size that is bigger than the RAM, then page cache is not working, and the fact that is working for a while is misleading, because like you may think you can rely on that, but at the worst moment, everything will just blow up, because if a memory access now is a disk access, and you can trash the page cache, then there's no chance to recover that, right? So we use a different strategy in BookKeeper. Like first of all, like typically we have the concept of journal, so that the journal is a append only and is dedicated to this, and it is fsync by default. So that gives you the durability guarantee of the data. At the same time, the data is also like staged into a write cache and later like indexed and flashed, right? And that serves the fact that we want to basically sort the data by topic and time, so that when we read, we can do like a huge strain of sequential reads, and basically like do a lot of read ahead and basically prop up our read ahead cache. But the most important thing is that the writes basically are only gated by the journal. So if you can write on the journal, then your write throughput is not impacted, and on the read side will happen on the disk. So these two like the write path and the read path are kind of like isolated disk-wise, and that's why we can basically like if a tenant starts like reading data, that sure will use some a portion of the disk IO or the read disk IO in the cluster, but it won't impact the writers that are writing and the latency that they are experiencing.
I see. I think that is a very deep kind of knowledge into like a huge addition to kind of multi-tenancies, because of the storage itself already provide the kind of physical read and write isolation, and that is a huge addition to like all the policy, all the mechanism provided in the broker level. I think that is probably one of the reasons why Pulsar choose BookKeeper as its default storage. And
Yes.
since we okay, since we kind of have less than 10 minutes, I would probably like touch to that question and to finish up our kind of conversation today. Like one of the conversation is so like the namespace is the namespace policy. Sometimes it's also a bit confusing. Is for people who like first time touch the system, they will realize, okay, is the all this limitation or this quota apply to the whole namespace, or is it like only applies to individual topics? And because that question would also help people to kind of plan their resource when they go to production. I would just like to see like what are your opinions or thoughts, or like to let the audience know and to share your experience.
So it is applied per topic, and so if you say that the quotas of like 100 gigabytes is 100 gigabytes per topic, and yes, so it can be confusing. I agree, because you store that on the namespace, it gets applied on all the topics of a namespace. But yes, so there has been plan in the past to have. So the reason that gets applied to that there's no like per namespace quota. You could have like if you have quotas on topics, like which you could do, like having number of topics per namespace, and therefore like you have an upper bound anyway, right? But it is that typically like it is more difficult to enforce the quota, because like topics for a single namespace can be assigned to different brokers, right? So that's the main. That's the main reason. So it is not impossible. Like there's been talk in the past about implementing that. We just never got the time and prioritization around that. But that's certainly possible to do it, both in terms of storage quota and in terms of like rate limiting, right? So there are like known techniques to implement distributed rate limiting across multiple nodes. So it is not like impossible to solve. It's that you just have to get that prioritized and done.
So given there's lack of this aggregate, I would say namespace level resource control, like what is your recommendation, or what is the best practice for people to plan their capacity when they go production?
I would say to have limits on the number of topics. That's one way to do it. So that you can plan on that. Like say that there can be only 100 topics. Each topic can have up to 10 gigabytes. Therefore, my very top maximum is this storage, right? That's kind of the idea.
How about Edson, since you adopt Pulsar, like when you go to production, how do you check, or how do you set those settings?
I mean, I think similarly so, right? And most of the time, at least in our experience, we were relatively generous and with some of those settings. Speaking to that same thing that Matteo kind of talked about much earlier of oversubscription, right? Like we don't obviously want to have to say, oh well, we've set this up so that potentially we have 10 terabytes of disk usage, when in reality the likelihood of that ever happening is approaches zero. Instead, let's set some reasonable limits to make sure that one topic doesn't go super crazy that may be misbehaving, and prevent that. And then if we sort of see growth that's happening, we capacity plan such that we can kind of find the likelihood of protecting against not I don't want to say bad actors in the sense, but mostly it's just bugs or whatever, downtime, and instead for the growth, the overall growth, that we have good metrics and good insight to help us see as that's happening, and then to add additional capacity. And so I see it as sort of two different problems, right? Like, use a lot of your resource quotas and whatnot to help prevent against runaway processes and the like, and then have good monitoring and metrics around some of how these other utilization things are happening to scale out your cluster as you kind of get outside of the range of running a little close to the edge. And that that's not there's no simple formula for that, right? Like, it takes a lot of measuring and tuning to kind of find out what that is, but it's not also a ton of different things you need to look at, right? Like, Pulsar's is pretty consistently going to be bound either by storage size, network throughput, or if you're having lots of topics, you're going to start seeing some memory or CPU usage, and those are all things that you can kind of get a good sense of pretty quickly, and then iterate from there and on growing out and scaling your cluster.
Thank you, Edison. I probably just asked the last question. It's probably not related to the access control and resource control, but it's somehow related to the topic hierarchy introduced by multi-tenancy. That is, Pulsar is able to support a lot of topics. And so then there's a lot of use cases coming, especially coming about IoT. And there's one of the common pattern that people usually ask: can I map one of my devices into a topic? And that means, I think my question is, for those use cases that would have thousands, 10,000, 100,000 of the topics, what is your recommendation in terms of like organizing them in the topic hierarchy? And because those topics might be related to each other, and they might apply similar namespace policy. Is it recommended to kind of put all the topics into one same namespace, or what would be the kind of best suggestion for those use cases?
I would say, go ahead.
Oh, I was just going to say, one of the rules that I like to think of is, if something has the same schema, oftentimes a partition topic can be much easier also to manage, because there's other factors to that. Primarily, if you need to consume across thousands of different topics, that actually can be somewhat difficult. But if you really do need that granularity, I'll let Matteo add his point. But if you really do need that granularity, you just need to really, I think, account for that in how you design and build your cluster. But generally, where possible, try and use a partition topic to kind of avoid some of that.
Yes. So yeah, partition topic is one, but if you have like this one topic per user kind of scenario, which is recommendable if number of users is not unbound, right? So if you have 100 million users, of course, or devices, you cannot do that, right? That's and even if you have a million, you can do that, but the amount of resources probably will be more than what you could use if you just design it in a different way, right? Because the fact that is sure you can do that, but you cannot do that with the I've been asking in the past, can I do a million topics? Sure. Can I do it with three machines? And say no, but my throughput is very low. But still, right? That's the way the design that a topic is. It is lightweight, but it is not that lightweight. So therefore, like if you just change your design, that's going to probably be much more efficient. But in some cases, it can be very convenient, right? And it can be also be a good idea if the number of devices it is not in the millions, right? If it's in tens of thousands, sure, that should work pretty well, right? And therefore, like if you want to basically like be able to administer like all the topics in one single shot, then probably there should be in some namespace, right? Because like there's no practical difference in terms of throughput or like being the instant namespace or being different namespace. So one single namespace is allowed to get spread across multiple nodes automatically and so on, right? But the only thing is that being in the same namespace, you can just retain the opportunity to basically configure them all at once. I don't know, so you want to change the TTL, for example, like you can just do one call and you change it for all 100,000 of topics and so on. So that's kind of like give more like flexibility and ease of operations, like instead of like having to basically make a REST curve and update for each one of them.
I see. Cool. Thank you. I think we are all kind of running out of time, and thank you for like watching this live stream. And for the audience that who still have questions and would like to discuss questions with you guys, is there any way to find you guys?
In the Slack channel, yeah.
Okay, so if you want to continue the discussion and talk about the multi-tenancy with Matteo and Edson, you can join Pulsar Slack channel, and you can easily find them. They are pretty they're basically active every day. You will see their name on the Slack channel. And thank you for watching, and hope everyone have a nice weekend. Bye bye.
Thank you. Bye.
Bye. Thanks, CJ.
Yeah. Thank you, Matthias. Thank you,
Bye.
Edson. Bye bye.